Good morning, ma. Now here in this syllabus we have already complete this. This part is completed, ma. Conditionals and recursions is completed. In this fruitful functions we completed return values, incremental development, composition. Next Boolean functions. Next Boolean functions up to we complete, ma. Here next topic is, ma, this is the Unit 1 assignment questions, ma. Unit 1 assignment questions. Unit 1 assignment, what is a program? How we are using comments in Python, and explain the process of running. Next, explain about different types of operators with examples. Next, you have to explain the following these type of statements: assignment statements, variables, script mode, and explain about functions with an example. Have to write these questions, ma. One assignment question. First, what is a program and how we are using comments in Python, and explain the process of running Python. Explain about different types of operators with examples. Next, you have to explain the following these. Next. This is the topic, ma, leap of faith. Here, leap of faith. Here, the flow of execution is one way to read the programs here. It can quickly become labyrinthine. Here, this is the alternate way. What I call the means, this is the alternate way. It called the leap of faith. It called the leap of faith. Here, when you come to a function call, instead of following the flow of execution, here when we come to a function call, you have to, instead of this flow of execution, we assume that function works correctly and returns the right result. This leap of faith we have to use in built-in functions. Built-in functions means already we predefined some functions. That is called the built-in functions, ma. Here next, this is called the, here it can quickly become the labyrinth, means flow of execution. It is one of the way to read programs. It is one of the way to read programs. That is called the here labyrinth. Here this is the alternate way. Here is function call. Here next. Here, for example, when we call math.cos var or math.ext. Here, when we call math.cos cos var or math.ext. Here, we are just assume that they work because the people who write the built-in functions, were good programmers here. We wrote the built-in functions, means we predefined these functions. Here, for example, he wrote a function called is divisible. It determines the whether one number is divisible by another. On the time here, for example, you take the Fibonacci function, Fibonacci series function. In this Fibonacci series, you have to define mathematical function is Fibonacci. Here, this is the following definition. Here, Fibonacci of 0 equal to 0, Fibonacci of 1 equal to 1. Here, Fibonacci of n equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. It's translated in Python. It look like this. Here, you have to see how to def Fibonacci of n. If n equal to 0, have to return 0. L if n equal to 1, return 1. Else have to return Fibonacci of n minus 1 plus Fibonacci of n minus 2. This is the Fibonacci program. You have to define a Fibonacci function of n. Next, if n equal to 0, if you give the value n equal to 0, for example, you take 3 equal to 0, condition false, we go for LE function. 3 equal to 1, condition false, we go for else part. Here return Fibonacci of 3 minus 1 means Fibonacci of 2 plus Fibonacci of 3 minus 2, 1. 3 plus 1. You have to go for another Fibonacci function. You have to find out these two functions. Means it is a recursive function. Next, you have to try this flow of execution. You have to try the flow of execution and having the small values of n here. But according to this leap of faith, we have to assume the two recursive calls. You have to assume the two recursive calls. Here correctly, you have to use the two recursive calls work correctly. Here then it is clear that here we get the right result by adding them together here. Here, according to the leap of faith, you have to assume there are two recursive calls work correctly. You have to two recursive calls work correctly. Then it is clear. On that time we get the right result. We have to add together. It is called a leap of faith here. Another way, you have to flow of execution, that is called the here leap of faith. Next topic is the checking types. Here, if we call factorial and give it 1.5, here have checking type, you have to check, getting error or not. Checking, is there any error in our program? How to check, how to give the types, how to check types. Next, here in this, for example, here if we call factorial and give it 1.5 as an argument, if we call factorial and give it 1.5 as an argument, here for example if you take factorial of 1.5, here runtime error, we got the here runtime error, means maximum recursion depth is exceeded. Here. Maximum recursion depth is exceeded, means here we get factorial of 1.5. We can't find the factorial of 1.5 here. Here it looks like it is infinite recursion. It's look like a infinite recursion. Means what is an infinite recursion? Infinite recursion can't reach that condition. It looks like an infinite recursion. That this is a base case here when n equal to 0. For example, we take there is a base case where n equal to 0. Here in the first recursive call, the value of n is 0. The value of n is 0.5. Here in next it is minus 0.5. It is a smaller. From there it is a means here more negative, but it will never be 0. Here next, if we call factorial here, give it 1.5. Here it is an argument. Here we get the factorial of 1.0. Here we get the runtime error. How to get the runtime error? Means here it is maximum recursion depth exceeded. It is called the here factorial maximum recursion depth is exceeded. Means we give the 1.5 here. Here it look like an infinite recursion. Here, but how can it be? Means here there is a base case. When n equal to 0. Here there is a base case when n equal to 0. Here in the first recursive call, the value of n is 0.5. In the first recursive call, the value of n is 0.5. Here in the next it is minus 0.5. From there here it is smaller. It gets smaller. From there it gets smaller, means more negative, but it will never be 0. But it will never be 0. Next. Here we have to check the types. We have two choices. How to checking types? We have two choices. What are the two choices means here? We can try to generalize the factorial function. We can try to generalize the factorial function to work with floating point numbers. We can try to generalize the factorial function to work with floating point numbers. Here we can make factorial. You have to check the type of its argument. Here we can make factorial, check the type of its argument. Here we have two choices. First choice, we can try to generalize the factorial function. We can try to generalize the factorial function to work with floating point numbers. To work with floating point numbers. Here we can make factorial, check the type of its argument. Here we can make factorial, check the type of its argument. Here this first option is called the gamma function. Here this first option is called the gamma function. Here in this we have two choices. We can try to generalize the factorial function to work with the floating point numbers, or we can make factorial, check the type of its argument. Here the first option is called the, here this first option is called the gamma function. Gamma function. Here next, here for example, here we can use the built-in function. We can use the built-in function. Here example built-in function is instance. Is instance to verify the type of the argument. Is instance to verify the type of the argument. Here this is the built-in function. Is instance is the built-in function. Here we are at it. We can also make sure the argument is positive. We can also make sure the argument is positive. Here def factorial of n. Def factorial of n. Here if not is instance of n comma int. Here def factorial of n if not is instance of n comma int. Here for example print function means here is instance means to verify the type of the argument. Is to verify the type of the argument. Here if not is instance n comma int. Print factorial is only defined for integers. Factorial is defined only for integers. For example, we gave the 3, factorial of 3. If not is instance 3 comma int. 3 comma int. If not, we give the here not. The condition is false. So we go for here 3 less than, here if not is instance n comma int. Factorial is only defined for integers. Defined for integer. Return none. Here we give the if n less than 0. Mean 3 less than 0. 3 condition false. That's why go for here 3 equal to 0. Condition false. Here next else part, we give the else part here factorial of, this is a factorial function. Factorial fact equal to factorial of n plus factorial of n minus 1 factorial. Here next, this is the we be using the is instance function. Is the is instance function. Here the first base case, here in this program the first base case handles the non-integers. The first base case handles non-integers. Here the second catches the negative integers. Here the first base case handles the non-integers. Next the second catches the negative integers. First base it handles the non-integers. Next the second catches the negative integers. Next in both cases the program prints an error message. In both cases the program prints an error message and have to returns the none to indicate that something went wrong. Here have to none means to indicate that something went wrong. That's why we are using the none function here. None. Here the program prints an error message. Prints both cases. If both cases are wrong, if both cases are false, on the time the program prints an error message and returns none. Returns none. N-O-N-E, none. To indicate that something went wrong. To indicate that something went wrong. Here, for example, we give the factorial of Fred. Factorial of Fred here. Factorial of Fred. Here, factorial is only defined for integers. Factorial is only defined for integers. None. None. We get the both cases are wrong. That's why we get the none. Here, factorial of -2. It is not defined for negative integers. That's why we got the none. If we get past both checks, that we know that n is positive or 0. So can we prove that the recursion is recursion terminates. Recursion terminates. If we get both checks, then we know that n is positive or 0. We can prove that the recursion is terminates. Recursion terminates. Next. Next, this program demonstrates a pattern. This program demonstrates a pattern. Sometimes it is called a guardian. Here, this program demonstrates a pattern, sometimes called a guardian. The first two conditionals here. This program demonstrates a some of the pattern that sometimes is called a guardian here. Guardian. Here the first two conditionals. The first two conditionals here. What are the two conditionals means here? First, you have to act as guardians and protecting the code that follows from values. It might cause an error. It acts as guardians and protecting the code that follows from values that might cause error. First two conditions. What are the two conditionals means? First condition is it acts as guardians. It acts as guardians and it protects the code that follows from values. It might cause an error. It might cause an error. Here, the guardians make it possible to prove the correctness of the code. Correctness of the code. Here, the guardians make it possible to prove the correctness of the code. These are the two conditionals. How to demonstrate a pattern? It is called a guardian. These are the first two conditionals. Act as guardians. Next, how to protect the code that follows from values. It might cause an error here. Next, the guardians make it possible to prove the correctness of the code. Correctness of the code. Next, that is about the checking type. That is about the checking type. Next topic is the importing with from. Importing with from means import module. Already we know about this module. You have to import. How to import? You have to import. Here Python provides two ways to import modules. Import modules. Two ways to import modules. Here, for example, you take import math. Import math function. You have to import the math function. You have to import the math function here. First you have to import, after that we have to use. First you have to import, after that you have to use. Here print math. Next, here module. We give here this is the module. Math is the module. Module name. Import. You have to give the import. This is the module name. Import. The syntax means import. After that we give the module name. Module name. Likewise here we get the module math. This is the output. This for this program. This is the output. Module. What is here? Here module. Math is the module. What is the module here? Math is here built-in function. It is a built-in. Math is a built-in function. Built-in function means already predefined. Here we give the module. Next we get the math. Next is the built-in. We have to already predefined functions. Here we give the print math.py. Print math.py. Math.py. We get the pi. Pi value is 3.14. We get the pi value is 3.14. Here, if you import math, we get a module object named math. Here, if you import math, we get a module object named math. If we import math, we get a module object named math. Here, this module object contains contains constants like pi and functions like sine, cos, tan, and exp. And exp means expressions. Exp means expressions. Here, if we import math, we get a module object named math. Module object named math. This module object contains the constants like pi, and functions like sine, cos, tan, and exp means expression. Exp means expression. Next, how to try to access pi directly. How to access pi directly. How to access pi directly. We can get an error. Print pi. You have to get an error. Means this is the math function. Means built-in function. You have to give the math pi. Like this. Print math. Here print math.pi. Give the like this. You have to give like this. Print math.pi. Math means in that math, this is the module name. We have pi, sine, and exponent. Next, tan, mathematical functions. These are the constants in this one. This is the module object. It contains the constants like pi and sine and exp, etc. Next, this is the. If we have to try access pi directly, we get an error. Means here this is the error. Trace back most recent call lost file std in line 1. This is the line 1. Std in means standard input in module. This is the name error. Means name pi is not defined. Next, two ways are, you have to import two ways. First way is the import math like that. Next, this is the alternate way. This alternate way means you have to import an object. From a module. If I have to import an object from a module like this, from math import pi. From math import pi, like this. This is a syntax. From math import pi means you can access pi directly. Now we have to access directly, means without dot notation. In last topic here, we get the error. We have to try to access pi directly. We get an error. Here you take here print math.py. We give the math dot. This is one way. You have to import. This is the import modules. We have provide two ways in Python here. This is the first way. Here print math.py. You have to give the dot. Here. Here you can't access directly pi. But you have to try like this. You get an error. Like this. Here next. That's why we go for the another alternative is from math import pi. And we can access pi directly. We can access here pi directly without dot notation. Here we get print PI, we got the value 3.14. Already we math module import na. From math import PI. You have to import this module. You know, we can access the PI directly without dot notation. Print PI means 3.14 like that. Here next. Or we can use the star operator. We can use the star operator to import everything from the module. Here we can use the star operator to import everything from the module. Here like that. From math import star. From math import star cos of PA. Got the here PA means here star means number of. Star operator means you can use this here star operator to import everything from the module. Everything from the module. We can use we can use the star operator to import everything from the module. That's why we are using the star operator here. Cos PI. Cos PI means cos PI value 1.0 like that. 1.0 like that. Next. This is the advantage of importing like this. Here, this is the what are the advantages and disadvantages means here in this advantage of importing everything. This is the advantage of import everything from the math module. Code can the code can be more concise. More concise means more clear. More clear here means you have to reduce the code by using the import everything from the math module. You have to import everything from the math module. We have that code can be more concise. That can be code is more concise means more clear. What is the disadvantage means a conflict between names defined in different modules or between a name from a module on one of your variables. Here disadvantage. What is the disadvantage means here we are having some of the conflicts between the names defined in different modules or between a name from a module and one of our variables and one of our variables here. Next. This is the disadvantage. This is the advantage. Advantage means you have to import everything from the math module. Means here what is the disadvantage means here we have some conflicts between names defined in different modules. Next. Next, up to this two topics, 2 chapters are completed in second unit. We are having 3 chapters in the 3 chapters 2 chapters are completed. Next, third chapter means first chapter. In second unit we are having chapter 1, chapter 2, chapter 3, 3 topics. In the 3 topics, second topic, third topic is completed. This is the first topic means case study. This is the case study here in this case study first topic is the turtle world. Here in this turtle world, here package. What's in a package here? Here package it is a collection of modules. Package is a collection of modules here. One of the modules in SWAM PY. SWAM PY is turtle world. SWAM PY is turtle, one of the module in SWAM PY. Here a package is a collection of modules. Here one of the module in SWAM PY is a turtle world. In turtle world, one of the module is SWAM PY. Here in this, it provides the SWAM PY means it provides a set of functions for drawing lines. By some steering turtles. Around the screen. Here SWAM PY. SWAM PY means it is one of the module in turtle world. Here it provides a set of functions. It provides a set of functions for drawing lines drawing lines by steering turtles around the screen. Steering turtles around the screen. Here, if SwampPy, it is installed as a package. It is installed as a package on our system. It is installed as a package on our system. We can import turtle world like this. We have to import turtle world like this from here, from here, SwampPy, where it is from SwampPy dot turtle world import star. From SwampPy is the module now. From SwampPy dot turtle world import star. Turtle world import star. That is the, we can import turtle world like this. We can import turtle world like this. Here from SwampPy dot turtle world import star. Next. Next, we have to download the SwampPy modules, but it did not install as a package. Here we have to download the SwampPy modules. Download the SwampPy modules, but did not install them as a package. Install them as a package. Here we can either work in a directory, but it contains the SwampPy files. Here in this SwampPy, we are having some of the files or add the directory to the Python search path. Here the directory to Python search path here. Here we can import turtle world like this. We can import turtle world like this. Here from turtle world import star. From turtle world import star. Here we have to go for the turtle world and we have to go for the import in that star, means number of modules we are having in the turtle world. One of the package is SwampPy. One of the packages we are using the SwampPy. Next. Next, for example, we take here create a file named. Here in this turtle world, why we are using this turtle world means you have to draw the lines. For example, in geometry we are using triangles, circle, polygons, next octagons. The diagrams have to draw. But we are using in Python language. We have turtle world. In the turtle world, you have to draw that diagrams, the geometry lines. You have to draw that geometry figures here by using the SwampPy module. Here, for example, here we have to create a file named. We give the file named is mypolygon.py. Here, and have to type this as the following code. This is the following code here from SwampPy dot turtle world import star. From SwampPy dot turtle world import star. Here old equal to turtle world. Here Bob equal turtle. Here print Bob. Have to give the print Bob. Here you have to wait for user. Here, for example, here from SwampPy. Means module name dot turtle world import star, means number of files in this import. You have to import number of files here. World equal turtle world. Bob equal turtle. You have to print Bob. You have to give print Bob. Wait for an user. Here in this first line, here for example, here in this first line it imports everything from the turtle world module in the SwampPy package. Here this first line imports everything from the turtle world module in the SwampPy package here. Here the next lines create a turtle world assigned to world and a turtle assigned to Bob. Here you have to printing the Bob yields something like this. Here you have to printing the Bob yields something like this. Means you have to give the turtle world dot turtle instance at some. Here you have to yield like this. 0x, 0x, B7, B, FFB. This is the code ma, and the color code are instance like this here. Here, this means that Bob refers to the instance of the turtle. It is defined in a module. It is defined in a module turtle world. It is defined in a turtle world. Turtle world. Here in this, this means that Bob refers to an instance of a turtle as defined in a module as defined in module turtle world. Module turtle world. Here in this context, instance means a number of set. Here in this context, instance means a member of a set. Member of a set. This turtle, it is one of the set of possible turtles. Here in this context, instance. What is an instance? Member of a set is called instance. Here this turtle, it is one of the set of possible turtles. Possible turtles. Here you have to wait for user. We give the wait for user. Wait for user tells the turtle world to wait for the user to do something. To do something. Wait for user. It tells the turtle world to wait for the user to do something. Means in this case, for the user you have to accept close the window. You have to accept close the window. But here wait for user tells the how to do something. To do something. That is the wait for user. Next, here see here in this turtle world provides the several turtle steering functions. We are having some of the steering functions ma. Here in this steering functions we are having FD and BK. For means FD means forward, BK means backward. FD means forward, BK means backward. Here left LT and RT. LT and RT means it is for left and right turns. Left and right turns. Here LT means left, RT means right. Here each turtle is holding a pen. Each turtle is holding a pen. It is either down or up. It is either down or up. Here if the pen is down, the turtle leaves a trail. If the pen is down, when the turtle leaves a trail when it moves. When it moves the functions. When it moves the functions means PU and PD. PU and PD. It is stand for pen up and pen down. Pen up and pen down. Here we give the FD. FD and BK means FD means forward, BK means backward. This is about the steering functions, ma. And LT and RT, left and right. You have to turn the left and right. Here each turtle it is holding a pen. Each turtle holding a pen here. It is either down or up. It is either down or up. If the pen is down, the turtle leaves a when it moves the functions. When it moves the functions. Here in this PU and PD stand for the pen up and pen down. PU and PD stand for the pen up and pen down. Next, for example, here to draw a right angle. How to draw a right angle here? Add these lines to the program. Add these lines to a program after creating a bob before calling. After creating a bob and before calling here. Waiting for user. This is the program to draw a right angle. How to write right angle means right angle. Right angle means here like this. Right angle means here like this. Here right angle means here wait for user. Forward, FD means forward, bob means give the 100 steps forward. 100 steps forward. Here this first line tells the bob to take 100 steps forward. Left means the second line tells him to turn left. To turn left. Here FD means forward, bob, 100. When you run this program, we should see bob move east and north. Bob move east and north, leaving two in segments behind. Two in segments behind. The first line tells the Bob to make 100 steps forward. The second line tells him to turn left. Here, when you run this program, we should see the Bob move east and then north, leaving to this segment, two in segments behind. Segments in behind.